Today I want to talk about web audio, and we have some slides. OK, that's great. And it will be focused more on users, user interfaces, and why it's important, why we care, and actually why we didn't before. Before we start, I'd like to tell a few words about myself. So I'm a lead guitarist. I'm a rhythm engineer. Wrong again. I'm a lead software engineer at EPAM. I live in Poland. I did some stuff with web audio before, mostly for guitar stuff. And I love to work with user interfaces and make users happy. So let's begin. Why our web apps actually more silent? We don't really implement any sound effects in our applications. We don't care about it. And the only applications that they do it wrong sometimes. So, of course, in web, the site is the main source of information for any user, right? As a humans, we get in 90% of all the information from seeing it. Yeah, and the last 10% are split actually between hearing, touch. Then we have touch, smell, and things like that, which are not really available, at least for now, at the web. So we're missing another communication channel almost all the time in all our applications. Dark patterns that I would like to mention. The only applications they do use some sound, right? They do it for advertisement, on autoplay, everything we love, and everything we can't really skip. This leads us, not us, but browser vendors, to some decisions, which I will mention later. But in general, it is what it is. But sound could communicate information in ways that improve the user experience, right? And we should care about users, because from business perspective, our users is our revenue, right? Developers are our costs, users are our revenue. So we should care about them. And actually, this statement that I use here is taken from material design tool research. And they have a big amount of work and research done here with examples and guidelines how you should use audio in applications. And that makes me curious why actually Angular material didn't implement anything like that yet. But we'll see. So why we should use sound? It could be memorable. You can just look at the picture, yeah, and you can hear something in your mind because it's so familiar to you, right? Something like this. It's memorable. It's like your brand, right? And you can use some branding audio as well, and it will users will recognize you by it immediately. Yeah. You can improve user interfaces, providing some feedback on user actions, yeah? Notifications, clicks, and things like that. Another example, yeah? We improving interface with sound, we giving feedback. What's going on? On enable, we have zing, and set zing on another tick, right? That's actually one of guidelines. So when you enable something, it should sound like major. And when you disable something, for example, it should be more dark sounding, yeah? Descending sounds. Also swipes, touches, we can improve them as well. Let's take more material example, yeah? We have ticks, and we can use some sounds on user selecting something or deselecting. And actually, I will use list as an example in my demos. Also, we can celebrate. Yeah, user achieved something, and we can make him happy with some additional sounds as well. Also, we can decorate our interfaces. Here we have some ambient sounds. But from web application perspective, we can do something on loading data, right? If your data loading takes some time, it actually would make users more happy to listen to some music or something. Not that long as you might hear on some phone calls, yeah, when they keeping you online. Not this thing, but something short and nice, it could work. So how we can implement and add any audio sound effects to our applications? We have an API for that, and it's here for years. Like, first it was implemented in simple HTML5 audio tags, then we got Web Audio API, and it's our main tool. And because of usage of dark patterns I mentioned before, browsers disallowed autoplay audio in browsers. So usually they require some user interaction. User should click, do something. Only then your application allowed to produce any sound. And today I will show two main types how you can use audio. One is to use pre-recorded files, load them and play. And the second version is how to generate audio right in your browser using some primitives. So let's start with audio files playback as more simpler way to use web audio. Why we would choose this way from practical perspective? It's easy to implement. It's we have a lot of free samples that we can download and use for free with a license that allows us to do commercial usage, right? But on the other hand, we need to manage them and mix different sounds, because sometimes you have situations when sounds might collide. Yeah, you have some, for example, tap sound, and at the same time you can have notification. You should prioritize them and make, for example, notification louder because it's more important action. Also, browsers supporting different formats, and we have a ton of formats for audio, and different browsers have different codecs, and it's a bit of mess. Also, we need somehow to preload our audio, right? We want user to wait when he clicks, for example, a button. We want him to wait when our audio file will be loaded. We want it to be already there in his browser and just play. But we need to somehow handle it ourselves in this way. How it looks like? Let's say we have an Angular application, Angular template. We put some audio, HTML audio files. Here we load them, and on click we have a method, play sound effect, right? We pass in some options to whether the option is selected or deselected. And this is how our basically method to play sound looks like. We get in a reference from template to this HTML audio element, and then we just call in a play method on it. That simple as it is. Here are some conditions because we have basically three states. Yeah, option could be disabled, selected, deselected, and for each of them we provide different sounds. So let's check it out how it sounds. So here I use actually sound samples provided by Material Design 2. They have a pack, basically zip archive with audio in two formats, WAV and OGG. And I use those for this demo. This is just basic Angular material list, and I added clicks. OK. We can also add our own branding, record some sounds ourselves. For example, I recorded some. I believe this would make your applications memorable, yeah? If you record some blues or something. OK. Also, as I mentioned before, we can celebrate, with the user some small achievements. For example, we made all our to-dos for today. Let's celebrate it. OK, I've done a talk. Yeah, I can go away. OK, what about formats that I mentioned before? We have a lot of them. Here we have just most common. Basically, we have WAV, which is the biggest because it's kind of raw audio, non-compressed, really. And basically, it's something we won't use for web because of size. Yeah, we have MP3. We have FLAC, OGG, and etc. But different browsers support different of them. So if we're using HTML5 audio tag, we can provide multiple sources. This is really similar to how we use images and picture element, yeah, but for audio. And browser basically chooses the format it supports from what we provided and loads it and plays. As easy as it is. The only thing we need actually to provide convert each file into few formats and to be sure that we're covering all our target browsers. OK, also, as I mentioned, we have ability to do pretty much the same without bloating our templates with actual audio tags. We can do it programmatically, creating an audio object. We provide a source, which is a path to our file. We load it and play. It's really the same thing. But basically, it's quite a bit of boilerplate, right, to play something. Also, there are some corner cases with, as I said, with multiple sounds at the same time. We need to handle this, or preloading and stuff like that. So there are some libraries for that. I will mention a few of them because it's a huge territory and the topic is really big. So we have, for example, sounds control, which handles sounds and loading like in games. We basically providing all resources beforehand. Then we giving them some keys, yeah, tokens that we will reuse later. If you ever use something like Phaser.js for games, they have pretty much the same workflow when you preload all the samples and then just play them calling by key. That's it. We have something already wrapped to Angular modules like NGX Howler, which wraps Howler.js. It has different approach how they handle loading and playing things, but in general, it's just the matters of syntax and things like that. They do pretty much the same things in different ways. And you can ease your workflow using such libraries. OK, that was it for like plain audio. But we can actually generate audio right in browser and don't mess with audio files loading. So when we can choose this, basically, in this case, our audio files will be in our code. And this gives us a bonus because our bundlers know how to split code, how to preload it, and things like that. So everything will be handled by Webpack or Bazel, whatever you use. And it gives us some flexibility. On the downsides, not every brand would fit like synths like electronic music, which these generators sound like. And it might be complicated sometimes. So Web Audio API provides us with a main object called audio context. And it's kind of our canvas where we set up in the sound chain. Any web audio chain is a graph, basically. You have nodes which you connect in the chain, and it reflects how you process the audio. Yeah? For example, we have source. It could be the same audio media element. It could be some audio nodes or whatever. It could be input from microphone, for example. Then we create a gain node. Gain node is just a node that amplifies or controls the volume of our sound. Because amplitude basically means volume. And we connect our source to gain node, and then we connect it to destination. Destination is a default system output, audio output that we have. But if we want to user to have ability to select something else, we can do it with web audio, but it's a bit more advanced stuff. But by default, it will output to whatever source is connected right now to your laptop or computer. So if we will, usually when we want to model somehow sound, we use sine waves, for example. In reality, sound is more complex. It's not that simple as a sine wave, but for modeling and understanding how it works, such a model is a great thing. So basically, if we take our sine wave, amplitude is a volume, how loud it sounds, and frequency is a note's pitch. Okay. Also, as a humans, we have a limited bandwidth, which we hear. It's generalized, like kind of standard to think about it as 20 hertz to 20 kilohertz. But in practice, in reality, all we are different. And our bandwidth actually depends on our own ears, and even more, our hearing degrading over the time. And when we became older, we hearing less high-frequency content. So it depends, but for standardization, it's taken like 20 kilohertz limit. But in case we have the same nodes here, how we recognize different sounds, for example, whether it's barking dog or wolf or different instruments. Is it a piano or is it a guitar? Have you thought about it? So we have something called harmonics. And this is what gives everything its unique sound. Even our voices, they are different because we have different harmonic content. So what is it? So let's say we have some note, and it has some certain frequency, some pitch. And if we will use fast Fourier transforms, we will get a graph like this. And on one axis, we have frequencies that are present in our audio. And on the other hand, we have amplitude, loudness, amplitude. So basically, our main frequency, which is our node, will be the dominating one with the biggest gain, biggest amplitude. But at the same time, we will have way more content on upper octaves, which will have less amplitude. And depending on which of those harmonics have which amplitude, it colorized, let's say, the sound. And that's why piano sounds different than guitar. So how we can generate sound in browser? For that, Web Audio provides us with a basic building block, oscillator. What it does, it produces some sound wave infinitely until we stop it. Normally, in electronics, oscillation is something you don't want in your designs. But on the other hand, we use them in things like synths, electronic pianos, and all this stuff. They use electronic and nowadays more software-based implementation of oscillator. And browsers provide us with oscillator nodes. What it could do, we can specify different sound waves. I will show what the difference between some of them. So basic sine wave, triangular, square, sawtooth. Also, we can provide an array of numbers describing any waveform we want. It's called custom, and we specify some frequency, what the pitch of a node we want to play. And we can play and stop the sound. For Angular, there is a great package called Angular Audio Context, because unfortunately, older browsers had some prefix API implementation, things like that, and library Angular audio context. It utilizes standardized audio context library, and it handles such differences for different browsers for us. So it's very convenient to use it. So how our simple sound would look like? We're creating an audio context, yeah, and telling him, please create an oscillator for us. We want our oscillator to be, let's say, sine wave. We set some frequency for it, and then we playing it for some period of time, yeah, the 200 milliseconds in our case. So how it sounds like? We can make some disco, right? Techno or whatever. And it's very primitive sounds that we can produce. And actually, here you see sine, triangle, sawtooth, and it reflects that which kind of wave we are playing on selection of each of those. Yeah, first one is sine, second one is triangle. And they have a bit different sounding, yeah. Even they have the same amplitude, exactly the same amplitude, loudness, right? But they sound to us kind of different volume levels. It's just our perception because of those waves. Okay, how we can improve it and make it more naturally sounding? We have something called ADSR, attack, decay, sample, and release, right? The thing is that when we play or even when we speak, we don't produce like exact amplitude right away because we have some ramp up, ramp down, and basically ADSR is a way to describe how our sound wave should start and end. Yeah, so we have some rising amplitude at the beginning, then we have small decay, then we have something called sample, which keeps it constant for some amount of time, and release. Then we ramping down our sound. And basically, it's the simplified model how any sound producing works. Again, as you've seen in previous beep method, we had some kind of boilerplate, and we don't really want to deal with on that low level. We can use some libraries. Here is just two examples. Again, it's a huge field. You can do a big research, like hundreds of different libraries, and they, again, implementing everything their own way, so different APIs. For my demo, I choose Tone.js. It's kind of most popular one. So as you can see, it's simpler. Our code is smaller, and our sound will be also a bit better. So we're creating some synth oscillator again. Under the hood, it uses the same oscillators, but enhanced with ADSR and things like that. And we providing some pitch, like note notation, yeah. G and A, and we specifying the length of these pitches. It's kind of, if you had in the past Nokia phones, they have this ringtone editor, and they use pretty much the same notation for it, basically. I love this thing. OK, let's hear how our improved beeps sound. Again, it sounds a bit more natural, right? Not that hard electronic techno stuff. So we can do pretty nice, interesting thing, and really similar to what, for example, Angular sorry, not Angular, but Material Design provides us in their samples. And it's just few lines of code. We can even do some polyphonic stuff, add some effects on top, and experiment with it a bit more. Let's hear this. Yeah, should be heavy. Maybe you can recognize even what the song it is. OK. And as I said, I touched only a bit of this territory of web audio, because each subtopic is kind of a big rabbit hole where you can dive deep. Because, for example, generation of audio and synthesizers and things like that, it's a huge topic. They do really advanced stuff sometimes. And if you want, you can go deeper. But if you won't, you can just use some library like Tone.js, and that's it. And it will handle your requirements and things like that. So what I try to do here is to provide some practical approach, how you can select and which way you can go, which library you can choose. But anyway, you will need to make own research and evaluate which library fits better your particular project. That's it for now, and please make your applications loud with some electronic music or bluesy guitars and things like that. Thank you for listening.